Jason with Tech Time Under 10. Today's video we're going to be looking at the startup of a penthouse mechanical room in a high-rise building. We earlier showed a video about startup in a boiler energy mechanical plant where our hot water bundles, our main boilers, and all the accoutrements and supporting systems that are there support the building as far as steam heat, hot water heat, and all those other essentials that we use in the facilities throughout the day. Today, in the top of the penthouse of this 4-story building, so this would be story 5, we're going to, again, do the shift startup, assuming that we have only one shift, and I am that shift person. So, again, I want to point out in a little different order, I think it's more appropriate to show everybody the startup board. So this startup board I wrote today that has the date, the location, and the issues that I want anybody to understand. So for instance, I have hydronic pump number 4A and 3A are inoperative. That's because there's some seal and gasket leaks. We have those shut off. Chillers and pumps that support the cold water chilling system are also turned off because it's very cold outside, so we're not going to need those for a little bit. The outside air temperature, also called OAT, you see those acronyms and different things for HVAC, is right around 29 degrees today. So usually we'll turn those chiller systems on right around 40 to 50 degrees outside air temperature. So with that being said, let's start our tour. In any mechanical room, it's very important that we understand and have a clean mechanical room. If you look here, we just did the floors over. I guarantee you, a month ago, these floors did not look like this. They were very tarnished and dirty, and it was difficult to be here without wearing a dust mask. So, taking over this building, we decided we're going to make this a 5 and 6S, which is a program under Lean Six Sigma. And we're going to clean this place up. To my left are pump schedules, valve schedules, and diagrams. In any mechanical room, we make sure that these are still here. So if I need to isolate something, I have all these schematics and diagrams at my disposal, and I know what valve tags do what. So if I look, I can see the tag numbers, what they affect. So the first one would be cold water, chilled water, hot water return, so on and so forth. So that's what those do. I look at things like frequency drives to make sure that they're doing what they're supposed to be doing. So I know this one is, because that's normal. As we said in the earlier video, to use your 5 senses, smell, hear, taste, feel, look, do all those things, because those are what's going to tip me off to make sure that everything isn't working well. So before I go too far, I want to make sure that all my systems are working. Everything here that looks to be normal in what's called an MCC bucket array. This is an MCC bucket. Long term, it's called Motor Control Center. This is what makes all my equipment run. These are the starter contactors that will energize the circuits to make stuff run in this plant. Also noting the proper lockout tagout kit, as well as the procedures and the logs and everything that goes with it. So one thing I'm hearing that I'm not liking, I hear a high-pitched whistle. So the first thing I'm wondering is, what is that noise? My chillers are off. This is my main scroll chiller. It's a 2-circuit chiller. So again, here's circuit 2, circuit 1. The dividing point is this bulkhead that's right in the middle. So I have basically 2 chillers on 1 foot here. That system is off. It's not leaking right now. My cold water pumps are not in the on position. They're not leaking. As well as my chemical feeders around the corner to make sure that my water tower is also well chemistry as far as the biologics, the Legionella, and bacteria, and algae, and all that kind of stuff. So that's what the chemical feeds for a water tower does. And if I want to, I can turn on my condenser water pump. That pump is the main. And the reason I'm doing that is to press through the tank. So the tank that's outside, I'll show you here in just a second, is basically idle water just sitting. So what I need to do is stir it every once in a while before we're using it, just to keep the chemicals from getting into it. This water tower is a heated sump. So heated sump means that in the wintertime, even if it's 10 below zero, this water will still be working in the hot. You can see the steam coming out from the hot water. This is what we use to cool for air conditioning system. The scale that's here needs to be knocked down. This is due for cleaning. We'll show you a video on that. Continuing around the penthouse mechanical room, a lot of the assets that are up here, those of you who have a handle on the old equipment, it's a pneumatic transduction system, and the pneumatics in this case are powers. So powers is a manufacturer of different air controls and electric transduction controls. This is my air handler. One of the things that I'm looking for is, do I have supply static pressure, meaning I have air pressure going to the building, and do I have return pressure coming back that completes the circle. Those are some things that I look at and the unit is running. Now I'm going to go to where we talked earlier about the boiler room, and that boiler providing medium to low pressure steam. I'm going to come up here to make sure that in my main steam manifold I have boiler pressure. And in this case I got plenty. I do have a pop-off valve right now that's blowing, so that's abnormal. I got to fix that. So I will adjust this valve down to make sure that this doesn't continue to happen. And that pop-off valve is designed to pop at about 15 psi. So right now it's not, because it's under, but it was earlier when I walked in with this video, and that is some of the things that we heard. I said, hey, this is a high pressure, or I'm sorry, high pitch leak that we were experiencing. So I have the basic PPE safety equipment on. Having insulated gloves would be a very big bonus, but right now I can tell you this should drive the pressure down. So righty-tighty, lefty-loosey. Right now I can tell you that this valve is probably a little heat down too much, so I'm going to start loosening it up to shut the valve down a little bit. That's how we adjust the pressures on these steam manifolds. So I'm going to try that. And I'll watch and see over time how this pressure is going to drop right here. Okay. As I continue to look around, I don't see anything earth-shattering, something cause for concern. But I am going to look at my pumps. So 4B is running. It's got good head pressure. I don't see any leaks. This pump is running. It's 3A. My hot water bundles and my heat exchangers are actually exchanging heat. And that's what these two things do. These are hot water heat exchangers, and they take regular fluid hydronic hot water that heats our registers and our reheats in the building, and it gets heat introduced by virtue of steam. So that steam goes all the way from where we just were, all the way down back to that steam unit. So that looks okay. Got my air dryer, my water separators for my air. Looks good there. My water. Again, here's air handler 3. I got supply static pressure. I got return. That means that it's a full complete system. It is doing what it needs to do. A lot of people out there, they say, hey, this is cool. I see these videos on urban exploring. And we look at what a building looks like when it's all torn down. This building is actually a hospital in the North or Greater Lakes region. This hospital has been recently shut down. And we have the benefit of being able to use this as a workshop and an education classroom. So that's something that a lot of folks never get to do. So our future series lot of this for us. We'll have different videos talking about pump rebuilding, road rebuilding. I see a steam leak coming from the packing right there. It's not a major deal, but I want to get that fixed. And this unit right here, air handler 1, is not running. I'm going to come down here and I think it's the old fuse stuff. I could tell this unit wasn't running because it was too quiet. Now I just turned it on. You can see the steam in the hot water. Yeah. That's all from the steam from the humidification. Not getting anything I can feel it yet. I can feel the air. Interesting, but this doesn't have any supply duct pressures or anything like that. It's really. Here's my cold water returns and my supplies for all my chilled water. So when we go into air conditioning season, that's what I'm going to focus on in future videos. Here's my domestic makeup water and my backflow valve. That's what the backflow valve looks like for the city. That's to make sure that no water goes back from my plant into the city and just for drinking water. Don't see anything weird here, unusual. And my chiller's off. So right now, my York, it's an older chiller, but it's a really good chiller by York. I highly recommend it. We're sitting here in really good shape. So on my way out, I went to turn off the pump, and I just turned on it because I stirred the water, so you can see the water flow right there. It's basically mixing chemicals into the water. And that's what that looks like. So right now I choose not to leave this tower on. Why waste the energy? I don't have patience here right now. And you see a benefit to anybody. To help our quality equipment by leaving this 3-phase motor. So stir the chemicals, there's my main strainer. Gets us everything in the room. Turn that pump on. Or off, I'm sorry. So this is what I do. When I come up, I'll turn the lights off, and we'll call this one a wrap. Thanks for joining me today on Jason's Tech Time Under 10. I hope to see you soon, and hit the like button if you really enjoyed the video. Thank you.